Okay, so in previous video we had stopped over here, and so so next is question number B. I have left it as homework for you. Okay, so if alpha and beta with the roots of this quadratic equation form an equation whose roots are this. So we have done so many questions of this type, so it's now it'll be easy for you to do. Okay, so please do. Now question number C. Given that alpha beta are the roots of the equation 2x square minus 3x plus 4 is equal to 0, find the equation whose roots are alpha plus 1 by alpha and beta plus 1 by beta. Same way we have to proceed. So alpha and beta are the roots of the 2x square minus 3x plus 4 is equal to 0. So we'll find alpha plus beta, that is 3 by 2. Alpha into beta, that will be 2. Okay, and alpha into beta, that is 2. Okay, and we are looking for the quadratic equation whose roots are alpha plus 1 by alpha and beta plus 1 by beta. So you know that equation will be x square minus sum of the roots into x plus product of the roots. So put these values. Okay, put these values, and you have to express them in terms of alpha plus beta and alpha into beta. Okay, so you got to simplify. So here alpha plus beta, I got 1 upon alpha, 1 upon beta, cross multiply. Here again I'm getting alpha plus beta upon alpha into beta, nothing I have to do further. Here I get alpha into beta 1 upon, so when you multiply you get this. Okay, and here you get alpha square plus beta square. So for this you got to do some simplification. Okay, so we have done so many times of this type. Okay, so we will get alpha plus beta whole square minus 2 alpha beta. Now put the values of alpha plus beta and alpha into beta and simplify it, and you get the answer 8x square minus 18x plus 13 equal to 0. Okay, I'm not going step by step. Okay, line by line. Okay, now question number 8. If one root of a quadratic equation be 2 minus root 3i, find the difference of the roots. Okay, we know that if the roots are imaginary, okay, then the roots are conjugate. Okay, so if one root is this, then the other root will be 2 plus square root of 3i. Yes, and we have to find the difference. So given 2 minus square root of 3i is the root of quadratic equation. So clearly 2 minus square root of 3 into i is an imaginary root, and we know if roots are imaginary then they are conjugate of each other, hence the other root is 2 plus square root of 3i. So all the time you don't have to explain this. Okay, so since it's a first question, so I wrote it for you to understand it better. Okay, so if you see that imaginary roots are, then the other will be conjugate of that. Okay, so now we have to find the difference. So here when they say difference, they have not said like first is subtracted from the second or second is subtracted from the first. They are only talking about the numerical value. Okay, the difference is this. So we write difference equal to this is mod. Okay, this is mod. Okay, like if I write mod minus 2, okay, then answer will be simply 2. Okay, means only the numerical value without sign. Okay, so that's why when we are talking about difference, we are talking about the numerical value without that negative positive one. Okay, only the number we are talking about. Okay, so that's why we have put it in mod. Okay, and then this 2 plus square root of 3i minus 2 minus square root of 3i. So you solve, you get mod 2 into square root of 3i. It is plus only, so simply we have to write plus. If there had been minus, still we would have written 2 square root 3i. Okay, mod means that. Okay, so if I have mod minus 1, then that is equal to 1. If I have mod minus 3, that is equal to 3. If I have mod 2, that means equal to 2. Okay, so mod gives you the absolute value without the sign. Okay, question number 9b. Question number 9b. If alpha beta with the roots of the equation this, so this is the quadratic equation and they are saying alpha and beta are the roots of this. Form an equation whose roots are this. So this is the quadratic equation. We know the alpha and beta are the roots. We have to form an equation whose roots are this. So what we'll do, first we'll find alpha plus beta and alpha into beta. Okay, we found that for this quadratic equation. Now we are looking for the equation whose roots are this. So you know that the quadratic equation whose roots are this is x square minus sum of these roots, okay, into x plus product of these roots. Now you know that you have to write this in terms of alpha plus beta and alpha into beta. Okay, here already alpha into beta, so no problem. For this you have to write, okay, so we got alpha plus beta, alpha square minus alpha beta, this. So this has been written by the formula that a cube plus b cube is equal to a plus b in bracket a square minus ab plus b square. Okay, and so here I got alpha plus beta, but this still you got to simplify it. Okay, so here do some manipulation, so you get alpha plus beta whole square minus 3 alpha beta. We have done this type before also. Okay, so check that, recall that. Okay, and then substitute the values and simplify, and you will get 9x square minus 28x plus 3. So this is the quadratic equation whose roots are this alpha square upon beta and beta square upon alpha. Next is question number 11. If the roots of ax square plus bx plus c is equal to 0, be in the ratio 2:3, show that 6b square is equal to 25 ac. So they are saying that this quadratic equation has got roots in this ratio 2:3. So let the roots be alpha and beta. Now according to question, alpha is to beta is 2:3 given to us. That means alpha upon beta is equal to 2/3. That means alpha is equal to 2 beta upon 3. Yes. Now you got this. Now further you know that the relation between you know the sum of the roots and product of the roots. Okay, so sum of the roots alpha plus beta is minus b upon a. Yes. So but alpha value just now what you got, 2 beta upon 3. So substitute 2 beta upon 3. So you got the value of beta. Yes, when you simplify you get beta. So you got the value of beta in terms of a and b. Okay, now further you know that product of the roots is given by c upon a. So now in place of beta you can put this minus 3b upon 5a in this case. Okay, so put now simplify it and you will get this 2 upon 3 beta square is equal to c upon a. Okay, and beta value this minus 3b upon 5a. Okay, put over here, then simplify it and you get this. Okay, and you will get 6b square equal to 25 ac. Okay, so in this question this information was given to you that roots are in this ratio. Okay, so you have to make use of this. Okay, so we got this. Okay, and the other two relation that we know, sum and the product, you have to use those also. Okay, and wherever you can substitute the values accordingly, substitute and you'll get the answer. So when you write this down, after that please go through this solution once again. Okay, question number 14. Question number 14. Find the value of m for which the equation 2x square plus 6x plus 3m equal to 0 will have equal roots, reciprocal roots, roots whose product is 9. So one quadratic equation is given and there is this m also. Okay, so they are looking for the value of m. Okay, so that roots are equal, Okay, so what should be the value of m so that roots are equal? Number one. Number two, what should be the value of m so that roots are reciprocal of each other? Number three, what should be the value of m so that the product of the roots is 9? So given 2x square plus 6x plus 3m equal to 0 is a quadratic equation. Now this will have equal roots when discriminant is equal to 0. So then d is equal to b square minus 4ac equal to 0. Okay, if this has real roots, that means discriminant is 0. That means b square minus 4ac is equal to 0. Substitute the values. Then you get the value of m, that is 3 by 2. So if the value of m is 3 by 2, in that case, that quadratic equation will have equal roots. Okay. Next, it's saying that what should be the value of m so that the roots are reciprocal. So suppose that the roots are alpha and suppose one root is alpha. Suppose one root is alpha, then other root has to be reciprocal, that means 1 by alpha. So we know that product of roots is given by c upon a. So here c is what, 3m, and a is what, 2. So product of roots, it will be 3m upon 2. Okay, now here they are saying we are looking for the value of m so that the roots are reciprocal. So here one root I have taken alpha, other root obviously 1 by alpha. So put these values. So you get alpha into 1 by alpha, that means 1. Okay, then you will get m equal to 2 by 3. So if m is 2 by 3, in that case roots are going to be reciprocal of each other. Okay, next we are looking for the value of m so that the product of the roots is equal to 9. So product of the roots of the equation, this is 9. Okay, in number 3. So we know that product of roots should be equal to 9. Okay, but you know product of roots is what, c upon a. So c is what, 3m, and a is what, 2. So put and get the value of m. M is equal to 6. So if value of m is 6, in that case product of the roots will be 9. Next, question number 15. Find the quadratic equation with rational coefficients whose one root is this. Okay, number 2, okay, find the quadratic equation with rational coefficient whose one root is this. So one root is this for question number 1, and for question number 2, one root is a minus root square root of b. So we have done so many questions of this type. Okay, okay, so given one of the root is this, then the other root will be this 5 minus square root of 3. Why? Because you can see that this root is irrational. Okay, and you know that if one root is irrational, then the other will be conjugate of that. Yes, so one root is given to us and it is an irrational, so other root is 5 minus square root of 3. Conjugate of this will be what, minus here. Yes, so let this be alpha, let this be beta, and sum of those roots will be 10, product will be 22. And you know that if roots are given to you, then the equation will be x square minus alpha plus beta into x, okay, plus alpha into beta is equal to 0. Substitute the values and you get the quadratic equation. Okay, so if you have been given irrational roots, okay, one irrational root is given, so other you know that other is the conjugate, so other you got over here, and now you have got two roots. Okay, so simply you can write the quadratic equation. Okay, same way you have to do this number 2 also. Okay, so that's why I didn't do that number 2. Question number 16. Find the equation with real coefficient whose one root is this. So here you can see the 4 plus 3i is one of the root of a quadratic equation. It is an imaginary root, so the other root is 4 minus 3i, conjugate. Yes, so given one of the root is this, then the other one is 4 minus 3i. So now you have the two roots. Okay, and rest you know how to do. So you know that if you have got two roots, then alpha and beta, then equation will be x square minus sum of the roots into x plus product of the root. Okay, substitute those values and you get the answer. Question number 18.2. 18.2. Find the values of m for which the quadratic equation this has equal roots, both roots positive. Okay. Now, when a quadratic equation has equal roots, when discriminant is 0. So for number 1, this is a quadratic equation and this should have equal roots. So this will have equal root if discriminant is 0. That means this should be 0. That means b square minus 4ac should be 0. Substitute the values and you are getting again a quadratic equation in m. Okay. So calculate that and you get m equal to 3 or m equal to 5. So for m equal to 3 or 5, okay, the quadratic equation will have equal roots. Okay. And the next they had asked, what should be the value of m? What should be the value of m so that both the roots are positive? And when we had discussed the condition for which both the roots are positive. Okay. If minus b upon a is greater than 0, okay, and c upon a is greater than 0, in that case roots are positive. Yes. So this quadratic equation will have both the roots positive if minus b upon a is greater than 0 and c upon a is greater than 0. So what is the b value over here? Minus 2m. So minus 2m. A is 1. So we get 2m greater than 0. Okay. And this side c upon a greater than 0. Substitute. What is the value of c? 8m minus 15. A value is 1. So here we get 8m greater than 15. So here 2m is greater than 0. That means m is greater than 0. Here m is greater than 15 upon 8. Okay. 15 upon 8. So here I got m greater than 0 and m greater than 15 upon 8. So we will take those values of m, okay, which will satisfy both of this. Okay. Linear inequation of class 10. You have to recall that. Okay. So you can see that if I take m something greater than 15 upon 8, okay, then that will be greater than 0 also and greater than 15 upon 8 also. Okay. So the quadratic equation, okay, will have both the roots positive if m is greater than 15 upon 8. M is greater than 15 upon 8. So this m should be anything greater than 15 upon 8. Okay. Okay. Now next question is, it had come in 2019 for 6 marks. Question says, find the value of p. Find the value of p such that the difference of the roots of the equation this is 3. Okay. So here one quadratic equation is given to us. This is the quadratic equation. Okay. And they are saying that the difference of the roots is 3. Okay. And we have to find the value of p. So this is a quadratic equation. Here we have got p over here. They are asking us to find the value of p. And one information that they are giving to us is the difference of the root. Okay. Difference of the roots is 3. Okay. And further they are saying that you may take the roots to be alpha and beta. Okay. So you can consider one to be alpha, other to be beta. Okay. And next they are saying you have to also find the quadratic equation whose roots are alpha plus beta whole square and alpha square into beta minus alpha into beta square. So they have given us a quadratic equation that is x square minus px plus 10 equal to 0. And they are saying that roots of this equation is alpha and beta. And they are saying that the difference of alpha and beta is 3. Okay. And they want us to find the value of p, number 1. And number 2, they want us to find the equation whose roots are this alpha plus beta whole square, alpha square into beta minus alpha into beta square. Okay, so let us see. Given alpha and beta are roots of this equation given to us. Further, they have told us that difference of the roots is 3. Okay, so here what do I suppose is, I suppose that alpha is numerically, okay, that alpha is greater than beta. Okay, I'm assuming that. So if I assume that way, alpha is greater than beta, then that way alpha minus beta is equal to 3. Difference they have said it is 3, so that means alpha minus beta will be 3. Next, we know that sum of the roots is minus b upon a. Okay, so alpha plus beta will be minus b upon a, but here what do we have in place of b? Minus p. So minus p, and in place of a we have 1, so I get alpha plus beta is equal to p. Okay, and next alpha into beta is equal to c upon a. What do we have in place of c? 10. So I get 10 upon 1, that alpha into beta is equal to 10. So number equation 1, 2 and 3, these 3 we are going to use, okay, to find the value of p. Okay, we are going to use this to find the value of p first. Okay, and then we can find the value of alpha and beta. Okay, so if you use 1 and 2, if you use 1 and 2, okay, you can see this. Here we have got simultaneous equation. Alpha minus beta is 3 and alpha plus beta is p. So let us use these two, 1 and 2. Okay, so when I add 1 and 2, okay, beta and beta cancel, so I get 2 alpha equal to p plus 3. So 2 alpha is equal to p plus 3, and alpha will be p plus 3 upon 2. Okay, and in next what I'll do, from the 1 and 2 only, now what I'll do, I'll subtract 2 from 1. Okay, then I'll get minus 2 beta, okay, is equal to 3 minus p. That means beta I will get p minus 3 upon 2. So I have got value of alpha in terms of p, I've got value of beta in terms of p. Now what I will do is, I will use these values alpha and beta in equation 3. Okay, in equation 3, alpha into beta is equal to 10. So from 3 we have got alpha into beta is equal to 10. So now I know the value of alpha in terms of p, I know the value of beta in terms of p. Substitute these values, okay, and I would get p square minus 9 is equal to 40, p square is equal to 49, p is equal to plus minus 7. So I got the value of p. Okay, it could be plus 7 or minus 7. Now I can use the value of p, okay, in this alpha, okay, in this alpha, and I can use value of p for this beta. So if I take p to be 7, because here I've got two values of p, plus 7 and minus 7. So if I take p to be 7, then alpha will be 5 and beta will be 2. Okay, in that case, in order to find alpha, you have to put this 7 in this equation, okay, and here. And when I take p equal to minus 7, I get alpha equal to minus 2 and beta equal to minus 5. Okay, minus 5. Okay, so we got this alpha and beta when p is 7. We got alpha and beta when p is minus 7. Now we are looking for the quadratic equation whose roots are alpha plus beta whole square and alpha square beta minus alpha into beta square. So if you have got two roots, then this is how we get the equation. So x square minus sum of the roots into x plus product of the roots. So simply put, okay, put these roots over here. Now what you can do is, we will substitute any of this pair, alpha beta this, either we put alpha equal to this pair, okay, or this pair, okay, because if you observe over here, no, either you put this or this, it doesn't make any change. Okay, if you put 5 and 2, okay, you'll get whatever value you get over here, okay, Same you'll get for this -2 and -5 also. Okay, because alpha minus beta is 3 only. Okay, either you use this or this. Okay, alpha into beta, for this will be positive only, and for this also will be positive only. So you put this or this, same. Okay, and here you are taking at the end whole square. Okay, same, because sum is also here, it's coming 7, here it's coming -7. So either use alpha equal to 5, beta equal to 2, or use alpha equal to -2, alpha equal beta equal to -5. So anyone. So now substitute. Here I have taken alpha to be 5 and beta to be 2. Substitute values of alpha and beta, and you get the required equation. Okay, so this is all for today. Okay, and next we'll see common roots. So this is all.